So I am delighted to be able to talk about Shengmao's paper today, Equilibrium Effects of Pharmaceutical Bundling, Evidence from India. It is an incredibly ambitious paper with a lot of moving parts, far more than 30 to 35 minutes will present me to get into the details of. So I'm going to try to hit all the high points and then go into some of the pieces in a bit more detail, but it's well worth the read. So I suggest this be your trailer of what the paper is like. Okay, so the setting of the paper is really looking at competitive bundling, which is a thing that we see all around us in the real world. And it effectively is defined as multi-product firms selling a bundle of goods at a discount to try to entice you to kind of buy that particular bundle. Now, as I said, we see this all over the place in the real world. We see that in bundled banking options. When you go on AT&T's website, they want to sell you TV and internet combined. When you go on Geico's website, they really would like you to buy auto and home instead of those two things separately. And they provide you with financial incentives to go and make that bundled purchase decision. Now, the economists have looked at these types of settings, but it's been really hard for them to draw kind of clear conclusions about the price or welfare effect of these types of bundling mechanisms because it's really hard to get kind of clean variation in whether or not something is bundled. What's really nice about this paper is that they're going to find a setting where bundling is not only potentially a little bit random, but also it's a place where bundling actually really matters from like a policy perspective. And so I think it's actually a really nice, important case study. So they're going to look at competitive bundling in the Indian pharmaceutical market. Now, what is a bundle here? It has a very particular definition. So we're going to think of one of these competitive bundles as a fixed dose combination, which is a pharmaceutical product that combines two or more drugs in a single pill. So I have a very simple diagram here, which is meant to demonstrate that. So here is a fixed dose combination for Alzheimer's, which is going to be their kind of case study within a case study. And as the presentation goes on, I'm going to butcher these names more and more. But this is memantine and donesipril in the combination, fixed dose combination here. But if you were to go to CVS and look for donesipril on the aisle behind the pharmacy counter, you'd be able to find it. You'd also be able to find memantine, and you'd also be able to find this. So instead of taking the drug A and drug B potentially simultaneously, you're going to be able to take those at exactly the same moment and exactly the same pill. So you can think about these fixed dose combinations as effectively being a subset of combination therapy. So combination therapy is when you're going to take multiple drugs to treat some condition. Here you're going to do it on even a more intensive basis in that you're going to take one pill and that's going to be the combination. Now we see these types of combination treatments all out in the pharmaceutical market. They're often developed in cases where it's kind of complicated to treat the condition and you need multiple drugs because they potentially have different mechanisms of action. So we'll see a lot of these types of combination therapies and fixed dose combinations in particular for the markets for treating HIV, tuberculosis, cardiovascular diseases, type 2 diabetes, and cancer. So broad therapeutic coverage in the market. Now you could think that kind of a priori, there are both good and bad things about these fixed dose combinations. So on the one hand, if you're really worried that patients are not going to be good about taking multiple pills simultaneously, you could think that one of these fixed dose combinations is great because you're now not asking them to take 5 pills, you might only be asking them to take 1. And so medication adherence might go up, and so we might expect that health outcomes might be better. But at the same time, kind of what I had in my head when I started reading this paper, but you shouldn't have in your head, is that you could think about a mad scientist kind of taking different products off the shelf and sticking them into one pill. And so sometimes that mad scientist might choose to combine things that actually shouldn't be combined. And so putting them in the same pill might cause some type of adverse drug-drug interaction, or you could have some types of overtreatment. So we see this, the authors report, when we think about fixed dose combinations that have a bunch of different antibiotics stuffed into them. You could think that one is sufficient, and we want to be really careful about over-prescribing antibiotics. So creating this fixed dose combination with 5 different ones is potentially going to be very harmful. So there's kind of a potential good and a potential bad. We're back in kind of ambiguous territory. Okay, what's kind of interesting if we're trying to fix ideas here is if we look across all different countries in the world and we look at how effective these FDCs are in penetrating the pharmaceutical market, you can see that there's quite a bit of variation country to country. And in particular, the place where the authors have decided to do their study is a place where FDCs have been especially effective at penetrating the market. So almost 50% of revenue in these drug markets is coming from these types of formulations of drugs. In other parts of the study, they're going to look at the US. You can see that it's quite different there, that we have a much lower revenue share. I think it's about 17% of drug revenue that's coming from these types of drug combinations. So you're going to see that there's quite a bit of difference across places. The authors are going to argue that that's mainly a regulatory issue, but at the end, I'll kind of talk about why you might have other concerns about this variation. Okay, so like I said at the top, this is an incredibly ambitious paper. They're going to do a lot of different things. I'm not going to be able to cover all of them, but just in case I have a worst case scenario and don't get to most of my slides, here's big picture what they're going to do. So in the first kind of third of the paper, they're going to develop this really nice theoretical framework that's going to build in drug demand and supply, incorporating the possibility that people are going to be exposed and potentially choose one of these competitive fixed dose combination bundles. They're going to show how different aspects or primitives in their model are going to yield kind of theoretically ambiguous effects on prices and welfare. Then they're going to move to the second part of the paper that's really nice and is completely model-free. They're going to use a bunch of really rich data in order to be able to understand how different parts of the model interact with one another. And they're going to establish a couple important facts, which gives some additional context when we go to the actual model estimation. And I'll talk about those a little bit later. And then in the last part of the paper, which is where I'm going to try to spend most of my time, they're actually going to do a full-blown welfare analysis where they're going to take their model and estimate it on the market for Alzheimer's drugs, which is very convenient because it's, again, both important and also it fits to the simplest version of their model. And so it's a great place to actually do the estimation. And what they're going to find, kind of previewing the big picture results, is that in the case of these fixed dose combination for Alzheimer's drugs, it's actually a win-win. So producers are much happier, consumers are much happier. We don't see these kinds of distortionary price effects that we might be worried about. And so it's really a success story. And if we're worried about potential regulatory barriers kind of disrupting which fixed dose combinations different manufacturers are going to bring to market, this is suggestive that maybe there are some cases where kind of loosening those restrictions is going to be a good thing. And I'll definitely unpack that as we go through. Okay, so big picture, that's what they're going to do. So let's start to think about the model. So in their model, they're going to think about a therapeutic market that's pretty simple. So we're going to have two drugs, drug A and drug B, and potentially we're going to have an FDC, so a pill that has both A and B inside of it. So if you think you're showing up to this market, you're in the market potentially for a drug in this therapeutic class, you can do one of five things. You can either decide that you don't want any drug, so you get the empty bundle. You can decide that you want only drug A or only drug B, or A and B, but separately, so you're going to take two pills. Or you're going to take a single pill, but it's going to have A and B in it. So you can do one of five things. Now, what's important about the colors here is that, remember, these are not going to be monopolist markets for the most part. And so you can choose to consume a particular firm's variety of a particular drug. And so when you consume drug A, you can choose the white firm's or the black firm's version of drug A. And in particular, when you start to be somebody who's in a combination therapy, but not taking the single pill, you can start to mismatch which manufacturer's product you're taking. So take the white firm for pill A and the black firm for pill B. And so this should start to kind of maybe percolate in your brain that this can have some issues welfare-wise. Okay, so now thinking about this in terms of equations. So if I'm consumer I and I'm choosing from a drug bundle R, what is my utility going to be? Well, I'm going to have some standalone value of choosing any of, consuming one of the drugs in that bundle. There's the potential that I'm going to get an extra benefit from taking these two drugs simultaneously. Now this kind of, we're going to talk about it as a positive thing. I think importantly, it could be a negative thing. So it could be bad that you're taking these two drugs simultaneously, but there's some kind of discontinuous effect or the possibility for one. And then, of course, you're going to have the disutility of having to pay for whatever drugs are in your bundle, right? Okay, so if you're now thinking about kind of the standalone value of drug A or drug B, it's going to be composed of this average product value and then two kind of taste shocks. So one that's drug specific and one that's firm specific. So for the drug preference, you can kind of microfound this that certain people are going to benefit more for certain types of drugs. Say they have a really severe illness and this drug is particularly good at treating you. You might have a positive shock for drug A. And then if you think that different firms are going to produce different quality drugs, then you might have some preference for consuming a drug that's made by a particular manufacturer. Again, this could be Sun Pharma in India. You think that they make really good stuff, and so you're going to have a positive shock for any drug that's being manufactured by them. Okay, now the last piece is thinking about the value of one of these fixed dose combination products. So again, because this is combining both A and B, it makes sense that you're going to have the components value of A and B because those are both in there. And then they allow for the possibility that there's some extra benefit or again cost of consuming one of these FDC products. So remember at the beginning I talked about maybe there's a benefit of convenience of only having to swallow one pill per day. You could think of that as being kind of a positive, and some of those kind of costly complications of taking something together that actually is harmful would give you something that looks like a negative. What they're going to emphasize later on in the model is that these preferences you could think of as being kind of factually sound or something that you perceive as a benefit or a cost. And that kind of gap between scientific reality and your perceived reality can kind of cause some distortions on the consumer welfare effects that we're going to look at later. Okay. So that's the demand side. What about the firm side? Well, firms are going to set prices under Nash-Bertrand competition. They are going to be multi-product firms potentially, so they're going to have multiple products here. They charge some price, they have some marginal cost of producing it, and they're going to choose the price to kind of maximize their profits across all the products in their portfolio. As we would expect, kind of the equilibrium prices can be found by this expression, where importantly on the mth element of that matrix, we're going to have a non-zero element. So you could potentially boost your price or reduce your price depending on these cross-price elasticities for the drugs that are in your portfolio of products. Okay, now two things that are worth emphasizing here. The first is that they're not going to do a lot directly with marginal costs, but you could imagine kind of two worlds where producing a bundle could give two different results for costs. So one is, I produce drug A, I produce drug B, I have some cost of doing that, and me producing the bundle is just the sum of those two costs. It's the exact same process, everything's the same, I stuff the same thing in the pill, that's what my marginal cost is. They're going to allow for the possibility that that actually is not the case, and that potentially it could be cheaper for you to produce that bundle than it would for you to produce those two things independently. So they're going to allow this thing to be estimated kind of indirectly and think about the potential for cost savings and how that changes the firm's problem. And then in terms of the equilibrium, they're going to do kind of the standard thing, which is to assume that the equilibrium exists. They have far too many moving parts here to actually do a full solution of their model. Conveniently, when they do the estimation in the Alzheimer's drug market, they only find pure strategy, pricing equilibrium. So we're content to make that assumption. Okay, so now I think the next kind of really interesting part of the paper is that they take that model and then they do a bunch of simulations to try to understand what moving around certain primitives does to prices and also welfare in general. Okay, so the first thing that we want to think about is the pricing of the actual fixed dose combination. And what they're going to show is that there's kind of conflicting forces on this price where some are going to push it down and cause firms to want to discount the bundle. And there's other things that are going to push that price up and cause them to kind of charge a premium for allowing that bundle. So the kind of what they frame as the most important effect that they're going to be looking at are these bundle discounts to attract one-stop shopper. By which I mean you're going to try to discount the price of your bundle to try to entice the people in this room to go and buy both A and B from you. Those are their one-stop shoppers. And what they're going to show is that as people have higher co-prescription rates, so they're buying both drugs before there's an FDC available, you're less likely to have these bigger discounts. So So you kind of already have a captive audience, and so you don't need to entice more people to come in. So you're not going to discount as much. But then remember that consumers also have these own idiosyncratic preferences for firms. And so if consumers really like your firm's products, again, you don't have to really entice new people to come in because you already have a captive audience. So these are things about consumer preferences that are going to kind of change your incentives to discount your bundled price. But remember, for people potentially could have their own preferences for these FTC products. And so if there's some premium that they place on an FTC, then you have the ability to kind of charge a premium, and that's going to push your price up. At the same time, if there's some cost efficiencies in producing these bundles, then that's going to have downward pressure on your price. So you kind of have a bunch of things pushing it down potentially, one thing pushing it up, and then cost unambiguously pushing it down. So who knows what it actually is going to do? We need to actually estimate the model to be able to say that. It also kind of hints that the setting is going to matter quite a bit, which I'm going to talk about at the end, hopefully. And then they think about kind of one of the big policy concerns, which is if I start to introduce this bundle and entice people to go for that bundle, what am I going to do about my component prices? So suppose I produce the bundle, but I also sell just A and just B. There are going to be some people who just consume those standalone drugs. And if my incentive is to push that price really high up to try to entice people to buy my bundle, then the people who are only buying those component drugs are going to be unhappy. So there's some welfare implications to that. But we can think that they might have an incentive to push the price of those component drugs up to try to lure people to buy their combo. But at the same time, in their setting, there's going to be quite a bit of competition in these different component markets. And so if the market is incredibly competitive, if I'm somebody who's making a bundle and push up my price of my component drug, then other people can enter, or they're already there and they're going to underbid me and I'm going to lose that market. So that's going to push my price back down. So again, we have things that are conflicting, not clear what's going to happen in our setting. And then they think about welfare. And what's really nice is they have this nice way of kind of thinking about two different things that could happen that are going to yield potentially conflicting results for welfare. So what's important is thinking about kind of what happens when you introduce an FTC, and who is going to buy that product, right? So you can imagine kind of two different scenarios. So in the first scenario, you introduce this FTC, and the people who are buying your FTC are new people to the combination drug therapy market. So they're people who weren't consuming any of these drugs previously, so they were in kind of the empty bundle, or they were people who were just buying A or just buying B. That's not shown, but that would be the same thing. That's thinking about kind of expanding the market of people who want to take A and B at one time. And they're going to say that in general, we're going to think about this market expansion effect as being welfare enhancing because we think that there's imperfect competition and probably prices are too high. So too few people are taking drugs relative to what a social planner would want. So we think that this kind of market expansion thing is a good thing. But we also have kind of the traditional cannibalization problem, where suppose I introduce my FTC and everybody who switches to it were people who were taking A and B already, albeit separately. So you're kind of gaining some market share, but you're just simply stealing it away from other people who were already in that business. And so we think potentially there could be an important cost because of this allocative efficiency. So remember, you can have a firm that's making A and is making a really good quality version of it, and firm B who's making a really good quality version of product B. And in a world where you're not bundling those two products together, you can kind of have the best of both worlds, get the high quality A and high quality B, although you're mixing firms. Implicitly, when you buy everything from a single manufacturer, you might be getting one high quality thing, but worse things on the margin for the rest of the bundle. And we think that that is actually welfare costing. So again, we have something that we think is positive, something that we think is negative, and it's ambiguous what the kind of total effect of this is going to be. Again, we kind of have these FTC preferences that are floating around. Depends on whether they're actually kind of scientifically informed preferences. If they are, then we think that probably it's going to be welfare enhancing. And if we have cost savings, that's unambiguously a good thing. They can charge less and everybody's happy to pay lower prices. Okay, so that's kind of what's going around in the background. Okay, what is, I think, another really impressive piece of this paper is the sheer magnitude of all the data that they've put together in order to do the project. So they're gonna have kind of all the standard things you're gonna look for, but also some like very unique data that's very helpful in their setting. So the first is that they're gonna have kind of aggregate P's and Q's by month from an Indian agency. They're gonna have, in their sample, they're gonna focus on tablets and capsules, which is kind of a convenient assumption that I have also made myself. It's nice because everything's measured in kind of milligrams, so it's easy to kind of classify things as being the same bundle and look at the component pieces. They're gonna have drug co-prescription information. So that's gonna be able to tell them how many people are taking A and B at any given time, either separately or in one of these fixed dose combinations. Importantly, they're gonna have this really nice e-pharmacy data, which is gonna allow them to observe people's repeated purchases of drugs, which is gonna allow them to really be able to look at very granular substitution patterns, both into FDCs, across component drugs, as well as within firm, which are all gonna be important pieces to identify kind of the parameters in the model. And then kind of the quirky piece of the project is that they're gonna use Medicare Part D PDE data, which is gonna be helpful because as you saw in that graph, the US is a place where there are far fewer FDCs. And so it's gonna be a nice laboratory for us to be able to understand kind of without FDCs floating around, how much do people wanna take different combinations of different drugs? They show evidence that the US is actually pretty representative of India, which I was surprised by, but that's in their paper and worth looking at. Okay, so what is important here? We need to observe relative to kind of the standard pharmaceutical market paper, aggregate P and aggregate Q are not gonna be enough here because it's really important for us to be able to see consumption of these different bundles. And we're gonna lose that if we just look at aggregate P and aggregate Q. And then, as I said earlier, it's really important that we see these substitution patterns because we're gonna need to identify different distributions of consumers' preferences, and it's gonna be hard to do that, again, if we just have P and Q data. Here, it's really nice. They don't have to make any assumptions. They can just read it right off of their e-prescription data. Okay, so now very quickly in the second piece of the project, they provide a lot of model-free evidence that's supportive of some of the theoretical implications that their simulations have. In particular, they're gonna first look at FDC pricing, and they're gonna find that often FDCs are actually provided at a discount in the market. So on average, about a 28% discount relative to buying A and B separately, but at the same time, if you buy them in the single pill, it's about 28% cheaper, which is significant. And then they're gonna verify that as there's a higher co-prescription rate, so think that more people are already in the market to buy both of those things together, they're gonna offer, manufacturers are gonna offer a lower discount on their FDC. Thanks. Okay, what they're gonna show with component pricing is once an FDC enters the market, component prices, do increase, but very slightly. And then they're gonna show that there's significant market expansion effects, or presumably market expansion effects, and very modest substitution effects. So here's one of the settings where I think a graph is super valuable. So what they do is they plot on the x-axis the co-prescription rate 1 year before FDC entry, and then they look at once FDC entry has occurred, how many people more are consuming both of these drugs. And what they find is that fewer people are taking the two separately, but a ton more people are just taking both of them. So that suggests that they're enticing a lot of people who weren't consuming both drugs into this market. Okay, so now let's look at the estimation of their model. So as I kind of prefaced at the beginning, they're gonna look at the market for Alzheimer's, two Alzheimer's drugs, dinezapril and memantine. And these are gonna be ones where the scientific evidence base is pretty supportive of both of them, as well as them being prescribed together. So that's the setting that we're in. In India, there are basically 5 firms that are in the market for these products. 4 of them were just making dinezapril, 2 of them were making memantine, and 1 of them was making both of them simultaneously. The first FTC was introduced in 2008, and as of 2016, 18 years later, everybody's in the market for it. So it's kind of in a new equilibrium. Here is their kind of model that they're gonna actually take to the data. They make a couple pretty small changes. One is that they're gonna make it now market specific. So instead of consumer I consuming bundle R, it's gonna be in market T. You're still gonna have the standalone value, the potential for some type of complementarity or dyssynergy, as well as a price. They're gonna add an idiosyncratic match value just so that they're able to actually fit the data, because as the model is specified in kind of the original version, if there's a bundle discount offered, nobody would ever choose to consume them separately. So they need that to justify the fact that there are some people that still do that. And then they're gonna kind of decompose the value that is associated, standalone value that's associated with A or B, by allowing there to be kind of a product time in some time non-varying value, as well as a drug product specific shock and a product specific shock. We still have the drug preferences, we still have the firm preferences, and we still have this FDC preference. Okay, how do they parameterize things? A lot of stuff is normal, all the consumer preferences are normal. They're gonna allow for there to be kind of a level shift in these preferences for or complementarities. And because, I don't think I said, but this epsilon is type 1 extreme value, they have market shares that can be written really nicely, as we all know. Okay, so now they have a very long discussion in their paper about identification. A lot of it is actually really nice. I'll highlight like 2 of them in the interest of time. So they have the kind of canonical issue with trying to estimate this price elasticity, because we think that product demand shocks are probably correlated with these prices. They're gonna use a really nice policy that kind of varies the prices of a particular drug product, but firm specific. So within a drug, they're gonna have product specific price shifters. That's gonna allow them to get at this price elasticity. And then kind of skipping to the bottom here, FDC preferences and cost savings are kind of floating objects at the end of their paper. And so they're gonna estimate these by looking at how off their model is from reality. For the cost savings, how much more they're offering discounts than what they would expect from their model estimation. And then FDC preferences, how much more the market is expanding relative to what we would expect with discounts. Okay. They're gonna use simulated method of moments, pick several moments from all of their different data sources, and then standard errors are gonna come from Bootstrap. Okay, I'm gonna fly through some of this stuff so I can get to my actual commentary. They're gonna estimate a mean own price elasticity of negative 2.36. There's not gonna be a level complementarity shock, but there's gonna be some people who do really value taking the 2 at the same time. Once again, they're gonna find that there's really large market expansion effects and modest cannibalization effects. So they're enticing people to take both of these products that weren't doing that before. And they find that FDC preferences are negligible. So it's not that people think taking one pill is convenient or taking one pill is dangerous. It's just that they have no kind of net benefit or cost from taking one of these products. Okay. Then they kind of write down their consumer surplus expression. They allow for the fact that kind of how you perceive one of these FDCs to be different than how scientists might perceive the benefits of it. Because they don't estimate any preferences for these things, consumer welfare is just kind of the standard expression. And moral of the story, what do they find? Well, really, when we compare a world without FDCs and firms setting prices relative to the world where there are FDCs and everything can kind of readjust, you see that there's a pretty significant welfare gain, so about 14%, and about 7% of that is coming from product variety, and most of it is coming from FDC discounts. So you're providing cheap discounts, that's why people are wanting to consume these FDCs. Again, it's a good thing for producers. Producers are also very happy with this. So it's kind of unambiguously a happy story. Now, the last piece of what they do is they say, okay, well, the regulatory environment is pretty lax in India. So you kind of maybe do have those mad scientists out there that are combining different things, and maybe not all of those are good. In the US, we have a really strict regulatory environment. So a firm that wants to make one of these FDCs has to jump through all the same hoops as another firm trying to get an NDA. And so maybe kind of this process and the fixed cost of doing those types of clinical trials is too costly for a firm given the net benefit that they might get from exclusivity. They show in their model, if we make each of these firms a monopolist and look at how prices of these FTCs would change, their price does go up and they do make a lot of profits, but it's much less than the cost of them financing a clinical trial. So in this case, maybe this barrier that we have set up in the US is delaying consumers' access to some of these FDCs. Okay, so now in the short time I have left, some thoughts. Okay, so one of their main predictions, and I took it from the paper, is that firms give smaller bundle discounts when consumers tend to buy both drugs from the same firm anyway. And what I found kind of interesting is from looking at their summary statistics, although I didn't show them here, is there's seemingly a lot of heterogeneity in kind of what firms look like across different markets and how concentrated different markets are. So some are hyper competitive, there's like dozens of manufacturers, and in others they're fairly concentrated. And I wonder if kind of the incentives of some of these kind of market expansion versus cannibalization are gonna vary systematically depending on how big you are. So if you're a small fish and everybody who consumes your product is consuming both A and B, it's probably, you don't really care about that because there's so many other fish to fry that you might still want to give a really big discount. So I wonder if you can kind of play around with any heterogeneity in these two effects across different types of markets or firms. I also think it's kind of interesting to think about if it's reasonable or not to expect that consumers know this gamma I object. You could tell a lot of stories given recent history that maybe they don't, and that they might have some biased beliefs about what those gamma I's are. It seems like at the end of the day, gamma I is actually like a science-based term. And so I wonder, given the evidence that we know about these Alzheimer's drugs, is it maybe surprising that we get that there's kind of no net benefit of taking these things? And that we get really negligible FDC preferences, because this is a setting where maybe we would expect that. So is there some kind of perception cost here that's important? They did a big deal about that in the FDC preferences, but nothing here, and I thought that was maybe interesting. And is it worth kind of revisiting the consumer welfare expression? They also make kind of the canonical assumption that product offerings are exogenous. Here, that seems especially costly because it's probably the case that firms are going to enter this market for reasons that have to do with something that's important. What I found kind of interesting is that in the US, we don't see as much FDCs. In India, we see a lot more, and a lot of them maybe are not super sanctioned scientifically. Some of them were kicked out. And so I wonder if that's important or helpful variation in their data to be able to disentangle kind of what types of parameters we would expect in certain markets. And then something I guess that maybe I'll end on is this figure. So when I finished reading the paper, I guess my takeaway was, oh, these FDCs are great. It's a win-win. And yeah, we don't want these types of barriers to prevent firms from kind of providing these types of FDCs. But when you look in their data, a lot of the action when we make FDCs available is from market expansion in markets where the co-prescription rates were like incredibly small. And so if you think that it's few people are deciding to take these drugs when they're both available, but then suddenly when they're available in a single pill, they try to take them, it suggests that maybe there's more distortion here in more markets than the one that they've chosen. And so in a sense, like maybe this Alzheimer's one is one of the ones that's cherry picked from over here, but actually for most, it's actually over here. And so these barriers maybe if it's a blunt instrument might actually be a good thing. And that's it. Thanks so much.
All right, so Shengmao, you've got about 5 to 10 minutes to respond, and please take questions.
Hi, thank you everyone. Thank you, Emily, for this very clear and generous discussions of my paper. I really learned a lot from my own paper. Discussions. Yeah. Thank you very much. So I have a few quick thoughts on the comments. So they're really good. And after that, I will be happy to take questions, and maybe we would like to talk more during breaks and after. Yeah, so this the point on this potential heterogeneity across different markets is a great one. So one big nice feature about the Indian pharmaceutical industry is that because of historical reasons, the government do not allow patents, right, in the 70s. So there was a very vibrant domestic manufacturing markets. So lots of firms are there. There are some drug markets where there are kind of 10, 20 firms producing each drug. There are some markets where there are much, much fewer of them. So I did try to do something along that line, but there's scope to do a lot more. So one thing we can look at is, for example, this incentive to increase component prices might be stronger if there's just one or two firms, because if you increase it, people are going to switch to your FDC instead of other standalone products. But if there are 10 firms, if you increase the component prices, people are going to switch to your rivals. So that's something I think we looked briefly in the past. We'll look at it more systematically. And related to the same point, like ideally, we would like to have variations like across different firms. Am I a small fish who's like everybody who buy from me is already buying both, but there's some other firm that is doing well just in one of them, the incentives are going to be very different. Unfortunately, there's a data restriction there, is that our co-prescription data allow us to see in total how many people are taking A, taking B, or taking them together. And we do not see for each individual specific firms what is the fraction of these three types of consumers. So our hands are a bit tied over there. But we do see a bit of that from the e-pharmacy data where we have diabetes and Alzheimer's drugs. So it's a kind of some important disease market. We can definitely look a bit more into that. Yeah, and on this, our result on the complementarity between and so there are two objects. So one is the big gamma is how much synergy or dyssynergy you get from taking both drugs. The small gamma is on top of that, what is the adherence value of potential cost from taking the FDC. And in Alzheimer's market, I was initially surprised by the lack of average complementarity as well. But the point I want to highlight is that this heterogeneity is pretty big. And as I read up on the medical guidelines and literature, it's kind of consistent with the facts for this disease. There are the guidelines that for people with like more advanced Alzheimer's disease, they tend to need both. And those are people with draws with big gammas. For people with moderate disease, a very slight disease, they just need one. And those will have negative synergy. That is, if you just need one, if you already take one, the additional value from the other one is limited. They are substitutes. So that the kind of the two things net out. And I think that's the reason we don't find the average big gamma there. But for the small gamma, what is the value of FDC? I was really surprised. So there's nothing. People that don't really prefer the FDC for the intrinsic adherence benefit, because I was going in expecting that Alzheimer's patients are the one who probably need the most help in keeping track of these drugs. The dosage, the burden of pills is the highest for them, and the adherence benefit will be high. But when I talk to people, one thing I learned is that in these markets, typically when people take these drugs separately, they often come with these dosing aids anyway. So 2 pills is in some packet that help them mimic some of those benefit of FDCs. Maybe that could be part of it, or it could also be it's just the model. We are missing something. It's not fully, totally correctly specified. Those are the potential reasons. And the last point that which I find that really interesting is to going back to that figure. So if I could, yeah. So yes, so this is there's a lot of heterogeneity across the board, and it's definitely true that the market that we pick, mostly because of its simplicity. So it's kind of a rare setting with just 2 drugs. I was initially more ambitious. I said I wanted to do hypertension and diabetes. There are 20 drugs. It's a big network of 100 different combinations. But it turns out it's beyond my skills to estimate that type of model. So that's kind of a choice for simplicity, but it turns out to be a specific setting where it's a win-win for both parties. But as Emily has pointed out, a lot of this huge market expansion happens on the leftmost part of this figure. So initially, almost nobody is taking the 2 drugs together. Once they combine to 1 pill, which is literally, they should be the same, all of a sudden, people, like 70% of people in the extreme cases, start taking both. And it's not conceivable this can all be driven by a 30% discount or something like that. So there's something potentially concerning going on there. In the paper, we did kind of 2 preliminary exercise on that. We should do more. One is that we just look at what these drugs are. A lot of the dots on the very left, they are antibiotic combinations. So we can think of potential hypotheses of why there's a big market expansion. One is these firms are predatory. So they have pressure to come out with new drugs, and they sometimes just combine different drugs and claim it's something new when it's actually not. And they kind of misguide consumers in taking them. That's really concerning. The other could be the physicians get lazy about diagnosis. Without these combinations, they may want to precisely tell, oh, it's bacterial A or B. With these combinations, they get lazy or say, oh, just take this. It can be A or B, just take it, which is also bad, especially when we think about externalities. So antibiotics, painkillers, definitely where this is the case where we want more regulations. And then with the Medicare Part D data, we look at that more formally. So for each FDC in India, we can look at how often doctors already use them together in the US. So when we plot that, we see kind of a bimodal distribution. There's a huge group where people just don't use them at all in the US, like antibiotics. And those are potentially concerning. The FDA, I think, is doing a great job in screening those out. There's also a group like on the right, like hypertension treatment, diabetes, where doctors are using the two drugs like all the time, 50% of the time, but they do not become a combination, potentially due to regulatory reasons. And those are the case where maybe the Indian way to do it would be good. So our takeaway there is maybe the FDA should look at the doctor's experience over a few decades and leverage that and make the regulation more flexible, more targeted in a way. Yeah. Great. Thanks again. Yeah, let me know if there are any questions.
Great paper. I have a couple of questions. One is, I was wondering if you've looked at launch prices versus long run prices of these FTCs, and if the price elasticities are very different over time. The other thing, it's more of a recommendation, maybe you want to separate out chronic diseases from acute diseases, because I think in chronic diseases, there is an additional component that when you take these fixed dose combination, to stop them, you might have to go back to the doctor again. Like if you're taking it separately, you can just stop one because it's not helping you that much. But now you have to go back to the doctor to get a new prescription for the single one. So there is additional cost associated with that, but not for acute. I mean, acute is for a short period of time. So maybe you can look at it separately for those two conditions.
Yeah, great. Thank you very much. So both are great points. So for the first one, we will look more systematically at that. In the Alzheimer's market, we don't see that. The discount is pretty stable. But a priori, we will expect, because inertia, brand inertia is an important feature, there's this potential incentive for firms to lure people in with a low price and exploit inertia to create these captive consumers. And that's inertia is something because the data is not quite up to it. Kind of we extract away from in the paper, but we'll look into that more carefully. This acute and chronic distinction, for sure. Yes, in the descriptive part, we look at the discount difference between them. We find a slightly larger discount for the chronic diseases of FDCs, but we are not totally clear about what's driving that yet. And this comment on this potential lack of flexibility in taking those FDCs for chronic diseases is one of the potential reasons why the FDC preference could be bad, because in terms of dosage adjustment or drug adjustment, it's just make it less flexible.
I also found the result that the Z is low quite surprising and interesting. It's interesting that you mentioned that there is so much heterogeneity. I wonder whether you could look at whether Z's are higher among people who are not taking a lot of other drugs. So it's not that the benefit of taking a combination of two drugs, if you're taking 15 drugs overall, is probably going to be quite low. And Alzheimer's patients presumably are also going to take, a bunch of other drugs. And I wonder whether there is some heterogeneity on that margin that you can pick up in your data to see if these are higher for people who are otherwise not taking a lot of other drugs.
Well, that's a great point. So we'll look into that. So for our e-pharmacy data, we can see some of that. it's not complete because when we try to talk to the firm, they kind of, we try very hard, they only give us Alzheimer's and diabetes. But because diabetes is big enough, we can at least look at whether this is also diabetic patients who take this other drug and look at something.
I guess
over there.
in other data, you could look at how common is it that people are taking a lot of other drugs when they have Alzheimer's, so that would explain why in this market you would assume that there is a high value of combination, but it's actually just because it's only 2 pills among 20, so you're.
Yeah, certainly. So in the Part D data, so we can see all the information, we'll be able to look at that. Great, thank you. Yes.
So this is a comment about both motivation and generalizability. Like when I think of, for the consumer, the main benefit of bundling is reduction of transactions costs. So like take insurance. Like I don't want to call and search for one form of insurance, much less two forms of insurance. And also like when I'm shopping for insurance or paying a bill, it's like it's one bill versus 2 bills. So like bundling these things together is a real reduction in transactions costs. When it comes to a pill, it's like I'm already in the pharmacy. It's the difference between buying 1 bottle or 2 bottles. It's the difference between taking 1 pill or 2 pills. It seems small to me, and I think this is captured by your like lowercase gamma. So like my prior was that your lowercase gamma was going to be small. You found that it's small. So like one, I'm kind of wondering, what do I learn about bundling generally when you're studying a market where, at least for me, I view transactions costs as being small? And 2, is there scope within the model to go in ex post and start messing around with your gamma, increasing your gamma, and seeing like what happens to prices, what happens to consumer and producer surplus when those transaction costs are large?
Yes, certainly that's a great point. So I think the model itself can capture the variation in gamma. It's like the small gamma is likely going to be higher, like insurance market is just reduction of hassles. It's something we can definitely move around and see what happens. In general, my expectation is that if those got the benefit, the reduction in hassle costs are kind of a real benefit. If we increase it, it's going to be good for consumers. Price is going to go up, but it's kind of a reaction, a secondary effect to that. So overall, it's going to be good. But if there are some cases, like we discussed briefly in the paper, where consumer perceive this bundle to be good when it's actually not, which could happen in the drug industry, then that can lead to distortion. It could be potentially bad. Yes. So what we see, the empirical exercise is definitely looking at a very specific type of setting that doesn't really map into that kind of more general environment, but the model has potential to do that. And actually, I'm in the actively thinking about similar project in the insurance industry, bundling the setting where that will come in more prominent.
All right, so we've got time for one more question and then it's break time, because I know that's sacrosanct to these things, so. Edward.
You present the case where drug companies are already making 2 drugs separately, consider combining them. Could there ever be a case where you have one company makes one drug, another company makes another, and they consider combining forces and combining their drugs? Could that ever happen in real life? Would that make any sense, or would they always want to compete, or have you thought of that?
Yeah, that's a great point. So empirically, that doesn't happen in my setting because it's a setting where most of drugs I look at, they are generic drugs. The recipe to produce it pretty easy. There are definitely cases that the firm used to just produce one, and it starts producing this FDC. They basically added this second drug to it. I do see in some other settings, like especially cocktail treatment for cancer drug, where it can be like inter-firm bundling incentive that's kind of richer. I expect there to be some interesting bargaining and price setting decisions. That's kind of a little far from the paper, but something I will think about. Sure. Thank you. Thanks again.
Thank you.